Hi, my name's Lewis, I'm from Revizto, and today we're going to be talking about how Revizto is able to connect the 2D and 3D environments together, be this the 2D, 3D overlay, or the 2D as a map to navigate the 3D model, or even just how, if you raise an issue in the 3D space, how it knows which drawing to place it on. So we're going to be covering how we sort of set up the drawings to do that properly, and also why it's important that the drawings are set up properly to do this. This session is going to be specifically around the way we do this from Revit. Hopefully in the future we'll be able to create other videos for the other platforms as well, but at the moment this is just a Revit workflow. So we're going to jump straight into Revit and get going with this one. I've created a demo project for this example. It's very basic, very simple. It's got a couple of levels and a couple of sections that are going to help to explain what's going on. But to get started we need to look at one of the plan views. And specifically within here, we need to look at the view range, and quite often this is going to be controlled by the view template. And this is something that's really important to understand because a lot of people just use the view template that has been provided to them by their company and don't really think about it too much. But sometimes we need to look a little bit deeper into it to make sure that everything is going to work properly. So in Revit, we have a view range. In the view range, we specify the top plane, the bottom plane, and the cut plane. These three planes are really important to the way that Revizto works, and I'm going to explain a bit more about this once we get into Revizto to show you how this works. But quite often what we see is a bottom plane of minus 1500, something like that, a top plane of plus 1500, and a cut plane 1200. That's quite a familiar one. That's kind of one that I've always used in my career previous to working with Revizto, so I'm quite familiar with this sort of setup. And as I said, this is quite often provided in a view template and no one really thinks too much about it. And typically it gives you a good view, so you don't need to change it too much in a Revit point of view, but if we are using Revizto, there are some things we now need to look at. So I'm going to OK that. We're now going to jump into Revisto. So back in Revisto, I've created a section cut that shows the view range sort of displayed on a drawing. So here we've got level 1. We've got the view range shown as green, which is the top and bottom plane, which is plus or minus 1500, and then we've got the cut plane at 1200. So this sort of now represents how Revizto is making that connection. So basically anything between those two green lines will be associated with the level 1 drawing. And we can show this if I overlay this into the model. We can then see this view range. If I come out, if I now create an issue and we place an issue on this slab, and I say done, I can go to my 2D and I can see it's also found that connection to level 1. So I can select that and I can now see that issue on level 1. That's all pretty straightforward, but then on this next sheet, what I've done is I've kind of replicated those view ranges across all the levels. And this is where it gets really interesting because the view ranges, as discussed, quite often are just generated from a template. They're kind of not really thought about. And if we look at this next drawing, I've then highlighted these areas. And these are basically areas that are sort of like dead spaces that the drawings do not pick up. So the view range goes plus 1500. The next level up is minus 1500. And basically we've got a 4 meter gap, which means that there's a 1 meter sort of area within the model on each level that isn't picked up by the level 2 drawing or the level 1 drawing. So if we then put this into the model as well, so now we can see this in the 3D model. We can see the view ranges, we can also see the hatch area, so we can see where these kind of dead spaces are. So I'm just going to adjust the section plane just to give a bit more context to what's going on. We're now going to create 3 new issues. In this case, we're going to create one below the line, one above the line, and one through the hatch pattern just to show how Revizto recognizes this. So I'm going to create my first issue and I'm going to place it on the slab and we're going to say done. I'm going to go back to my 3D space. I'm going to create another issue which we're going to place sort of above the line and we're going to say done. And finally I'm going to place one sort of in this hatch pattern region. So I'm going to place that one there and say done. So now we're going to the issue tracker. So the first issue that we created, which is this one here on the slab, if we go to the 2D space, we can see that it's picked that up on the level 1 drawing. So that one's working perfectly. We can then go to the second one, which we raised above the line, and we can see that shows up on the level 2 slab, on the level 2 drawing. So again, that is working perfectly. So it's being picked up on the relevant drawings based on the drawings view ranges, and that's all good. We then look at the third issue that we've created, which was created in this dead zone. And you can see that the only drawing this shows up on is this section. It doesn't show up anywhere else. And what that means is that any issue that is created within Revisto that is located within this 1 meter band is never going to show up on a 2D drawing. So when you're doing the review process, when you're looking at the drawings to see the issues, anything in this zone is going to be missed. And therefore, you're not going to see it on 2D. You're just relying on the issue tracker in the 3D to do it, which is fine. But a lot of users quite enjoy using the 2D space as a way of filtering. And this is going to prevent that from happening really well. So this is one of the areas where we need to go back into Revit and look at the view range and understand what we're doing with it. So that's what we're going to do. We're going to jump back into Revit now. So in Revit, I'm going to look at my view range for my drawings. At the moment, I know, just because I've created this one, that I've got a 4 meter gap between every level. So there's a 4 meter story height, which makes it really simple. And the template works really well. On a real project where your story heights might be different, this is where you might need to unselect the view range from the template and control it separately per view. But in this case, it's going to work for me. So I'm going to go into my view template and I'm going to go to my view range. And now I'm going to adjust these 1500s to be 2000 and minus 2000 and minus 2000 for this one as well. And I'm just going to say OK and OK that. And then we're going to export this into Revisto. And I'm going to export the sheets as well. And I'm going to export that. Happens pretty quickly. And then it's going to open Revisto for me. So now that the view range has been updated in the model and the drawings that we've exported into Revisto, the really good thing to see here is that if we go into the issue tracker now, we look at the issue that previously was in that dead zone, the one that you can see here. But we can now see over in the 2D space that it's now picked up on a drawing as well. So it's now actually showing on the level 2 plan. And that means that it's now automatically going to be picked up on the plan views when we review this. So this is really useful because it's happening automatically just by changing that view range. And this just really sort of demonstrates how important it is that this view range is done properly when you do the exports, just so that you can ensure that everything is picked up. And again, if I just show this one more time, we can go, I'll overlay this into the model again. I'll just expand this out a little bit further, or I'll put it so I'll just pull that out a little further, and then we can close this. We can then again raise an issue in what would be the dead space, say done, and again now that one automatically is picked up on the correct plan view as well. So just by adjusting that view range and re-exporting that information into Revisto, everything is now picked up on a drawing. The other key thing, because we haven't changed the cut plane within Revit, the drawings don't really change. Like how the drawings appear in Revit don't really change. They look pretty much exactly the same, but we've just allowed the top and bottom planes to sort of meet, which means that every issue that we now create in Revisto is going to be picked up. And this is the same for issues that are brought in through like things like Navisworks or imported as BCF from Solibri. If they were located in this dead space, they wouldn't show up on a drawing, whereas now they will. So this is a really useful thing to think about when you're producing your plans in Revit, just to make sure that Revisto is going to pick up everything in one go. So that's everything I wanted to cover today. Just to go back over what we have gone over today, we've talked about how the view range in Revit is really important to allow Revisto to pick up all of the issues on their correct drawings. And this is shown again here. If we look at this drawing, making sure that the top and bottom planes mean that they meet, just so that you don't end up with any of the dead spaces like we've shown kind of here with these original view ranges. This is kind of key to the way that Revisto is working, and getting rid of these dead spaces is really important. It's also really important because it just means that your Revit drawings are actually covering the entire model and you're not ending up with any of these zones. But for Revisto specifically, this is really useful in ensuring that every single issue in the issue tracker appears on a plan drawing as well, which just makes it the review process when you're sort of working through the issue tracker. You can go to a 2D drawing, you can just see what's at that level, and then you can work through those and fix those really quickly and really easily. So it's also really important to understand that the view ranges, as we've done here on this drawing, they don't need to meet in the middle. So you can have the top plane be, 3.5 meters, and the bottom plane being minus 500 millimeters. It doesn't really matter. It just means that if we made this plus like 3.5, anything that was sort of appeared up to like this level here would show on the level 1 drawing, which is actually something that you might want to do. So understanding the view ranges and how they work best for you is entirely down to you. It's completely kind of up to you on how you do it. But different ways in which you can control it can give you different outcomes, and it's just really useful to understand that as well. From a time-saving perspective, and just from a Revisto perspective, this is a really useful thing to ensure that your Revit drawings are set up correctly so that there are no gaps between them and everything is shown. So yeah, I hope you enjoyed the session. If you have any questions, do reach out to your Revisto contact. I'm sure they'll be happy to show you this in more detail if needed. But yeah, I've been Lewis. Thank you very much, and speak to you all soon.